everyone. I would like to give you a warm welcome on behalf of Codurance to our meetup. My name is Przemek. I'm software craft person at Codurance, and I'll be acting as a host for today's talk. Our presenter is Javier Martínez, a data engineer and our good friend. In the meeting, we'll discuss two useful Python packages, Pydantic and Tenacity, to improve our code's quality. So a quick reminder that this session will be recorded, and you can find it and all of our previous sessions on our YouTube channel. Please take a look in your free time, and remember that Codurance was born from the community, and giving back to the community is very important to us. If you feel like you have a topic that you might want to share, feel free to reach us and we could help organize it. We would like the session to be dynamic, so we encourage you to participate and interrupt and ask all the questions you need. You can do it by speak up or write it on the channel. Now I leave you with Javier. The stage is yours.
Thank you very much for the nice presentation. Well, my name is Javier. We are going to talk a little bit about two interesting packages that we have in the Python ecosystem. Okay, I will guide you through this talk, this meeting. Okay, let's start. Be Pydantic and Tenacious. So these two things are in the common language not so popular, especially Pydantic. But especially this one is the one on which we will focus or set the focus today. What I want to set maybe in your brains or in the community is that these two packages provide a lot of values to reach your goals. Because each person has different goals in life, at work. Let's clarify the framework. I mean, for goals, what I mean is to code happily. So enjoy what we do while coding and developing tools. The second goal is provide some value, not only to you as developer, but also to a product, to your company, or to your community. And the third goal is to make your life easier and making also the life of other people easier. So these packages will provide or will set us towards these goals. But we have to start from the beginning a little bit from some background. Okay, the thing is that Pydantic, and we will see it later, is related with typing. And typing, I don't know, most of you know, probably all of you, typing is the way in which we describe how a software assign and manage data to specific variables. Okay, this is how the compilers or the interpreters assign data to different variables. Okay, we can divide this typing in two main groups, which is the dynamic typing and static typing. The first one is the typing, dynamic typing is the one that we can find in languages like Python. Okay, and this means that we don't define the type of the variables. Is during the runtime, during the execution of the program, that the engine of Python supervise and control what is the different type that is assigned to the different variables that we have in our software. Okay. In the other side, we have the static typing, which is the strategy in which we just use labels in our code. So we are coding, we are typing, and we define, okay, this variable will be an integer or will be a string. So when we compile, because this is usually linked to compile languages, the compiler in an intelligent fashion is able to see whether there will be any conflict because the variable is receiving a wrong type or a type that is not supported. Okay. And there is a kind of third type of typing that we use a lot in Python, which is it's called duck typing. And it's called duck typing because the sentence that I put here, basically, if it walks like a duck and it quacks like a duck, then it must be a duck. So in this strategy, we don't care too much whether a variable is of one type or the other. We care more about which are the methods that the class of that variable implements. Okay, so we are not collide or have an error if we are using two different types for the same operation, if the two different types implement the same methods. Because this is some or could be a little bit fussy. I will invite you to jump a little bit to the code. Okay, you can find it in the background folder. The idea is that you can try it yourself in real time. There are really simple examples and not much to install. So to provide some idea about what I just said, I said in the background folder just a simple script in which we will have the dynamic typing example function. We will have a static typing example, and we will use some self-made or custom-made class myInt. Okay. But let's execute it. We can execute it by going to the background. Oh, we have to run Python background and typing. Okay, this is the output, and I will explain it to you what is interesting here. The interesting thing here is that the first example shows a little bit how Python works. Okay, so we have here at the top a list of possible values, which is just a list in Python, and each element of the list is or has different type. Okay, the first one is a string, the second an integer, the third is a float, then we have a dictionary, and then we have a noun. Okay, so in a random fashion we print it here, and for example we have two floats, the dictionary and the noun time. Okay, but the key point is that the variable result is getting these values, so it's getting, or it's open to receive any value. Why? Because the interpreter in Python is taking care that this could happen, okay, without any issue. On the other hand, we kind of simulate what could the compiler in other languages work like, defining that this check here in which we assign again a value to the result variable, but we impose that this result, the type of result should be integer. Okay, so we have the first case in which we have an error. Why? Because we are getting a dictionary. The second case, okay, everything went pretty well because we receive an integer and we check for integer, so everything works well. So this is the kind of static typing. Static in the sense that, okay, we know that result will be always integer, so we make some logic to ensure this. And the third part of the execution shows a little bit how duck typing works, okay? And it's related with this self-made class. For this, you need to know that we can define, we can inherit from the base integer, okay, in this class, and then we can perform the same operations we do with integers. like add two numbers, okay? And we have that 353 plus 7 is 360, okay? But they are not integers. They are my own class, my own type. What happens? If I try to iterate through an integer, it's not possible, and we will get an error. So indeed, we can try like I have a 333, and let's say I want to for digit in a print digit. This will crash. Why? Because the class integer, the base class, is not iterable. Okay. But what defines an iterable? An iterable in Python could be any object that defines two methods, iter and next. So inheriting from integer, we can create an integer that has these two methods and then behave like iterable, okay? And this is what we said before, that if it's a duck and move like a duck and quack, and then it's likely a duck and should not be any problem. In this case, we have the same for loop here at the bottom, and you can see how the loop behave, printing the different digits. Okay, good. I will go back to the other desktop. Okay, we have this background. We know that typing is important and provides some safety net. So, but dynamic languages provide this dynamism in which we don't have to worry about which type is this variable and which is not. So this is this slide. So in Python we use dynamic, or we consider it as a dynamic language, dynamic typed language, and we use duck typing. But when Python got more mature, when it evolves, it becomes that it sounded like a good idea to implement some kind of type labeling, okay? And this is how the PIP 484 pop up and describes the more or less the whole framework of hints. Hints in Python are like labels that we can write in the code and that will not have any impact in the execution, okay? The decision of the choice of the community was that we will have some labels, but the core of Python will not work with that. Will be always a dynamic language, dynamic type language. But this open a window for third-party tools to check or perform some kind of static checking the types. From this third-party software, perhaps the most known and used is MyPy. Okay, and again we are going to focus a little bit on these hints with some examples. Okay, and you will see that this is important because Pydantic use or is one of these third-party libraries that use these hints. We can go together to the hints folder and we can check what is happening here. Okay, I will go out of IPython, pip run Python, and we can go to the hints and execute hints. Okay. Let's see. This is a trick because this was initially commented out. So if we run it, okay, we have that the next execution will not fail, and we have hello typed Javier, and the second will not fail, and type also, and type Javier. Okay. In the file, in the script, we have two functions. The first one used annotations, and annotations are these things here. Okay, before in Python, you work like this, but the hints open the door to write this, and this will be interpreted as labels, so will not be taken in account for the execution. This part here is also a hint or annotation that is telling us that we expect to get out of the function to return a string. And this, of course, well, of course not, but this is telling us that name should be a string, okay? But it does not enforce the type during the runtime, okay? So when we run these two functions, both run without any issue and provide the same output, okay? If we uncommented the other cases, what we have here is that we are running hello with hints with 3, which is an integer, okay? It's not a string. And hello without hints with 3, okay? And in both cases, if we save, of course, we will have an issue, okay? We cannot concatenate a string to not integer, and the whole program will crash, okay? This is kind of dangerous because, okay, this is really short piece of code, but imagine you have thousands of lines, and one of these errors or even data coming from a different service can enter your system and generate an issue, okay? So the hints or the third-party tools that we have allows us to run MyPy pip and run MyPy. Missing target. Oh, 1 second. Okay, sorry. Pipem run MyPy. Okay, so MyPy, sorry, I missed the target. And it was telling me, but I entered in panic mode a little bit. So the point of hints is that using tools like MyPy, MyPy will complain and will tell us that hello with hints has an incompatible type, hint integer, while we were expecting a string. This is not fancy. I mean, from people coming from other languages like Java or so, this is really common, but in Python, this was new. And this verbosity, apparently, and in practice, bring a lot of value. As you can see, MyPy is not complaining about anything of the function without hints because has no information to complain, okay? This function has no hints, so MyPy has no way to tell, oh, this will be right or not, okay? But if we include hints in our code, we will have a tool to easily run it before launching or releasing the piece of software that we have. And probably we will skip some errors, okay? now we have seen what is typing. We have seen how hints or annotation helps Python software to be debugged and to be maintained, because when you are in a large project, is or brings more value to maintain the code and make the code easier to read for other people than other thing. Okay. So why is this important? Because Pydantic, this piece of software, this package, is based on hints. Okay. Pydantic is mainly a parser. So it's a translator, let's say. It grabs a piece of data based on a model that you define, and it ensure or impose validation, but also type checking. And then, so if we summarize the features, and there are more, but I don't want to extend this presentation too much, we can say that Pydantic will check or put some checks on data classes, perform some validation, helps in serialization, deserialization, provide schemas that then can be translated to Open API. It has a wonderful documentation, and the last part, why I find it really interesting, is because it's integrated in the lightweight framework FastAPI. So if you use FastAPI or you want to use it, you will get really fast if you learn how to use Pydantic. Okay, I will describe it a little bit later. But let's check with some examples. Okay, let's check with the code. Here we are again in our IDE. In this case, you can go to the Pydantic folder. Okay, this is a bit larger, so let's review 7 features that we have. Okay, and let's check what we have. In my experience as engineer, I found really useful, well, people working or coming from Java knows that the value of having data classes. Okay, it's kind of a nice tool, and it fits pretty well with the hexagonal architecture and with the domain, the modeling of the domain and the entities. Okay. In Python, we have the library data classes for that. But let's check what we have when we execute this piece of code. Let me pipm run Python. Okay, and let's explain it a little bit. So what we have here in our, let's say, imaginary business is that we process orders. And yeah, don't complain too much if an order has an ID, and then probably should not be a data class. Let's imagine that is the case. So for setting the different properties of the data class, we help us with hints, like you can see here, the hints that we just mentioned before. Typing is a library really common for defining types. So I recommend you to check it if you don't know yet, because it defines more complex types than the vanilla ones. Okay. What we are going to do here is to generate an order, and this with this parameter: ID1, country Spain, date time now, Rodriguez workshop or Rodriguez workshop, and we order the elements are 10 nails and 1 red paint bottle. And this is a valid order. I mean, we have it here, and this is a valid order. Okay. What happened? What happened is that we had a similar order, but instead of an integer, we are passing a float, and there's no complaint. So this ID that should have 1, or at least an integer, is having 1.33 periodic. So it's invalid. And even worse, we have a we have a case here in which we have a list. There is no problem during the runtime. There is no error here. Okay, if we do like before, like executing mypy, okay, this is a bit better, no? Isn't it? We have that order has incompatible type float expected int, okay? And order has incompatible type list int expected int. So basically what I just said, that we were expecting an integer and we don't have, so it's an invalid order. In this sense, mypy is helping, but it's not helping during the runtime. So Pydantic helps in these situations, okay? If we switch to this Pydantic example in the same folder, we see kind of similar situation. Instead of using the data class package, we will use Pydantic, and we will inherit from the base model. This is the way of using Pydantic, okay? Inheriting from base model and then building our own models. We define the properties in the same way: integers, string, a list, and datetime, okay? Let's run it and let's see what we have. Sorry, this is a spoiler. It's not mypy, but let's run the code. Well, this is okay, no? Because we just run mypy and we got the same the same type checking. We got the errors as before we did with the data class. With Pydantic, we got also the errors, okay? But checking the situations that we had before, we can see a little improvement. Why? First of all, when we got a float, Pydantic is intelligent enough to replace or parse this float to an integer. Okay, this is not always possible. It's not always possible that you can cast. Cast is just changing from one type to the other. It's not always possible to cast from one type to the other, but in this case, an integer is possible to be cast, or a float is possible to be cast to an integer. So Pydantic does it and proceed with no error, which is a valid order in our case. But what happened with the list? The list is impossible to be cast to an integer, okay? Because it's much more complex. So Pydantic then crash, okay? And provide this validation error. This validation error can be print and will present a human readable message, okay? Which is this part of here. There is one validation error for order ID, value is not valid integer, okay? Integer here, and we receive a list. So during runtime, we got that error. And this is really powerful, despite it's really maybe simple, because allows us to take some actions during runtime without crashing, okay? Or crashing, because we don't want corrupt data in our database, for instance, or data lake. At the same time, Pydantic provide a JSON format for the same error, which is this. And this is makes your life also easier because imagine that you are implementing an API and you receive data from an external client and you got this error. So you already have the error in a JSON format just to send it back to the client in a proper format, in the common format that many clients out there, especially web clients, are implementing. Okay, so it's easy to analyze. This is just by using the basic functionalities of Pydantic. It's powerful, it's a nice syntaxis, and it's powerful, I think. In many languages, also in Python, we have some variables, some types that are immutable. And this is a condition that is pretty interesting. Why? Because protect us to corrupt our own data by source of noise, error, etc., etc. So if we execute in this example, we are in the folder 2 this time, and we run it. So we got order is immutable and does not support item assignment. Okay. What we have done here is with a nice syntactic sugar, set a flag allow mutation to false. The class config within the class order is not common, but it's a nice way to encapsulate a config that is used by Pydantic to set different parameters. Okay. And setting the allow mutation to false make the order, the instance that we have created, immutable. So when we try to update the country from Spain to Colombia, we crash, and this is good. We got a type error, and this is really powerful because then we can act and ensure that this is not an error. I know that many languages probably has really these features inbuilt or built from scratch when the language was born, but in Python, I think this is really powerful. Third property that is interesting, abstract. Abstract is also a common thing, at least for me, when I am defining new interfaces. I always, most of the time, try to set an abstract class with abstract methods that then later on I can inherit and implement the real implementation of those methods depending on the interface. Okay. In Python, the package for that is ABC. Sorry, Pydantic is compatible with that. So as you can see, we have the class order as before, and we can add an abstract method. Okay, allocate elements, and if we call it and it's not implemented, we will raise an not implemented error. Okay, exception. Later on, what we can do is derive. Okay, instead of inherit directly from base model, we can inherit from order and implement a new parameter that is allocation states and the real implementation of this method. Okay, allocate elements. So in this way, if we, sorry, I will clear a little bit. In this way, if we just execute the code related to abstract, we see that we can work with that. Okay, instead of creating an order, we have created a hardware order. okay, because we have a hardware shop. And this new order, this time, implements the allocate elements in the way we have specified before, not the abstract method, but the concrete, the specific method, okay? So I think this is a powerful replacement or surrogate for data classes that we have seen before, this feature. More about features of Pydantic or how to work with Pydantic. Okay, let's go and talk about inheritance and composition. Let's run it same as before. Okay. In this case, we have the same class as before, order, but we modified a little bit the elements. Instead of having a list of a string, we have a list that accept two types, the element and the explosive element, okay? The element is the base model or inherits from the base model and has two parameters, the name and the amount, okay? And the explosive element inherit from element. So it has a name and amount within, but extend the parent class implementing the explosivity, okay? Because this is for hazards or explosive materials, imagine. When we create the order this time, we can, instead of having a list of strings, we can we can append or attach the specific element. For example, the nail or the red paint are regular elements, but the explosive belongs to the explosive element and has the methods inherit from element and the specific method of explosive element. Okay, so this is a valid order, as we can see. But what happened, as before, we try to set or append, remember in this time, the model is mutable because we didn't change or made it immutable. So we pass explosivity equals to unknown, okay? But with this literal, we said that we can have only three options, high, medium, or low explosivity. If you provide unknown explosivity, there will be a validation error, okay? And this is Pydantic working behind the curtains, ensuring this, which I think is really powerful. And as before, we have the human readable error or human format error and the JSON error, which is nice. So we have seen in this example that we have inheritance in the form of explosive element inheriting from element. We have also the composition of elements as a composition of different classes. Okay, good. Serialization. This is also a nice feature. Sorry. Let's go back to our beloved order example. And we will check serialization. We have just this, and we have this output. Okay, what I want to show you here is how the syntactic sugar or the capabilities of Pydantic make relatively easy to work as a validator, transcriptor of an API. In this case, we define our properties in a snake case, okay? Order ID, country, order at, follows the regular Pythonic way of naming variables with a snake case. But it's really likely that if we receive the information from a client, we receive it in camel case, okay? Because the client is written in JavaScript and they follow this camel case or whatever, but there is a different case for the variables. And this will be a class, okay, because we will have camel snake case, but what we receive is camel case. Okay. One feature of Pydantic is that it implements aliases. Okay, you can define alias for the different properties of the method of the class. Sorry, and you can define it one by one, or within the config class, you can define an alias generator, which is a function that will be called to generate the alias for all the properties. Okay. In this case, what I have done is to use humps, which is a common library, in this case for Python, which has a, a function called camelize that converts snake case to camel case. And I set the flag of allow population by field name. Okay, not only by alias, but also by field, so by both. Okay, what we have in this example, we generate this order with a snake case, so it's possible. We generate a valid order. You can see we have a valid order. More, we can call the JSON method, and we tell the method that we want by alias true. So what we will have when we transcribe it to JSON, for example, to send it back to the client, is again the camel case. Why? Because it's using this function. Okay. In the in the other way, it also works. We can just define or call the order with the aliases instead of the name of the properties. So we can use camel case and not a snake case. So we can use both, and it's really flexible and it's really neat, I would say. We can, as before, print it, have a valid order. And what if we have an external body? Because we receive a call, and this is the information within that body. Okay, what we can do is to use the parse object function method to parse that object into a valid object. So from a dictionary or JSON format to an object from our domain, which is pretty cool. Is relatively flexible because instead of using this, we can just use or pass the external body dictionary as a keyword argument to the constructor of the class, of the model. Okay. Okay, serialization. It's easy, no? With working with JSON, serialize, deserialize. What about another nice property, a bit of validation? Let's see what we have if we run this example here. Okay, we have a valid and we have an invalid. Let me explain you the goal of this example. We have the same order, okay? But because we are really concerned about criminality in our city, we can set a validator. For what? For the elements property. And the validator function will be called peacemaker. And peacemaker is a class method. That's why the CLS here. B is the value that will receive this property elements. Values are the previous values, previous validated values, okay? And these keywords is for whatever thing you want to put there, okay? And what the logic is doing is to evaluate V, so the elements within this list, and if we find the gang word, it will raise an exception, and it will print this warning to you, which is what we got here. Okay, we create in our script the order in the same way, and it's a valid order as before. But what happened? Now Kingpin is trying to order 10 shotguns. So our validation, or validator, sorry, will detect that there is gun here, and will raise this exception. Okay, this is a dummy example, but you can imagine many more complex validations that can be implemented. And for me, this syntactic sugar is really, really, really neat. Okay, so far so good. Last thing, I cannot skip a presentation without talking about FastAPI. So the main reason for me to start working with Pydantic was FastAPI. The reason behind that is that FastAPI implements and use extensively Pydantic within the behind the curtains. Okay, it uses it for validation. It uses it for the same things we have done with our element order. FastAPI implemented. So if we run in this case the example, the FastAPI example, what we will have is that we raise a. Can you see the browser?
Yes, we can see it.
Okay, cool. Well, there is nothing, but let me show you one neat feature of FastAPI. FastAPI has implemented within the Open API. And you can wonder, how is it possible that it gets these schemas? So I mentioned before slightly, but Pydantic can generate also schemas. I didn't show you because I want you to check this more visual example. But thanks to Pydantic, FastAPI is able to construct, to generate these different schemas, and to perform the validations of the different requests to your API, which is, in my opinion, really powerful. And that's one of the, I think, the secrets of the success of FastAPI, probably is Pydantic. Okay. That's mainly all the examples about Pydantic. So it's true that Pydantic is more verbose, and probably the name is a proper name, is more Pydantic, but it's elegant, is good. It will help your team, it will help yourself to maintain the code, and it will help you also in runtime, something that the static checkers will not do or will not provide. Take home message: be Pydantic, because explicit and precise makes your life and other people's life much easier. So language, natural language is a trap. Be Pydantic, be really explicit. And in addition to Pydantic, be tenacious. And what I mean is just use tenacity, and this will be much faster than talking about Pydantic, because this is like the salt on top of the delicious piece of meal. Tenacity is a package for retrying, and it does it in a really elegant manner or fashion. Okay, you can check, and we can check together. You can find some example. Okay, imagine that we are sending some message through a channel. So run Python Tenacious, the default. This is the default. Hi world. Well, Hi there. Oh, we got an error. Why? Because the connection is broken. This is relatively common. I mean, there is a small problem with the communication. There is too much delay or whatever stuff out of your control, outside of your control, um, and your application crash. Okay. The solution for this usually is to retry. Um, Tenacity is doing that. Is trying to be elegant, provide a decorator, and using that decorator in front of your method send to this noisy channel, it will retry. Let's check if we can just run it. Hi there. Okay, we have 1, 2, 3, 4, 5 times. Okay, why? Because it took 5 errors. Hi, sorry. Javier, this time 4. So my point is that instead of crashing miserably, trying to implement yourself whatever you try, reuse this. It's really elegant and has many options. Okay. I will not go deeper into the example because you can read it later and it's relatively clear. If not, you can send me an email. I will be really glad to answer your email. And this is the same situation um, where I put, I comment different options that we have within this retry, within this library. Taking account that for using weight exponential or other thing, maybe you have to import them. But basically, you can imagine what happens if you use stop after attempt. So it will make 4 tries, and if none of them succeed, it will crash as before. You can stop or wait until a fixed amount of time. You can wait for an exponential amount of time, which is the common thing. You can retry if there is an output of your function that you didn't expect, like none, or if there is a specific exception that was recent in your function. Okay, and the and the last thing is that you can, the last improvement, let's say, is a double improvement, is that Tenacity works with async, so with coroutines, and also in addition, on top, to work as a decorator, you can just put it in a chunk of code, and it will work in the same fashion without having to define a function for that. Okay, because this is just the sugar or salt on top of the cake, sugar better than salt, and this will be the last the last thing. And let me go back to just this. Remember, set your goals and find useful tools to achieve them. I hope you enjoy coding. I hope you enjoy using these functions. And that's all. And I'm open to any question or discussion that you want to talk about or comment here.
Yeah, maybe I will start. I have one question regarding Pydantic. So when you're developing a code on your local environment, then how often do you run this analysis? And second part of the question, if do you know any plugins or tools that could automate the process, like maybe plugin for editor or something like that?
Well, most of the time I use Pydantic is when I'm using FastAPI. So as I showed you before, to what I do to running the different APIs I have to work with is to to set the server, in this case Ubicorn, which is an ASCII server, and everything, or all the Pydantic tools will be working behind the curtain. So if I define a model, imagine that my domain has orders, elements, users. What I do is to define this in the domain layer, let's say, and ensure that the inputs or the requests that are coming from outside fulfill this, and this works perfectly locally. So there is no constraint. On top of that, this is really, now that I mentioned this, the definition of the domain. There is something I didn't want to enter because it's complex and it takes more time, is the ORM. So it's really likely that you work with an ORM like SQL Alchemy, or I don't know, whatever in other languages, to interact with the database. Okay, you don't want to do your own queries, you want to get it attached to the domain. So there is a link or a way to link the models in Pydantic with the models or the tables defined in the ORM. Okay, but answering strictly your question, I run it every time locally when I have to test an endpoint or so.
Okay, thank you. So any other questions? You can write them also on the chat.
For the new people and for the people that are still using Flask, which is really valid and has a long tradition, to give a try to FastAPI, and well, it will be linked working with FastAPI and Pydantic. So work with Pydantic models. Check how powerful is the fact that you can have the schemas generated and then use open API without, I mean, this is really common case, at least in my experience, that people or the backend implement faster than frontend. But people are, or QA can test the backend with a graphic interface, which is the open API. And this sounds really simple, and it is, but it brings a lot of value.
Yeah, it seems like it's very good for some kind of crucial data, right? Place when you're putting data, exchanging it, like APIs, as you said, or object relational mapping, right?
Exactly. And I show you just the more common types in Python. As I mentioned, the typing library implements more complex types, and Pydantic work with them pretty smoothly and nicely.
Okay, so thank you very much, Javi, for this very nice presentation. Yeah, we have one comment from some Sergey. So I don't have any questions. However, the functionality looks cool and I should get to know it better. I've liked very much the part with inheritance and compositions. Thank you very much for such interesting presentation. Yes, thank you very much, Javi.
My pleasure to be here. And I'm really open. I want to remind this at the end of the video. You can reach me by email. In the repository is open. Feel free to open PR, change it, or make any comment that you consider. Okay.
Thank you very much, Javi, and thank everyone for participating.
Yeah, thank you to Codurance for the opportunity.
It was a pleasure for us.
To the whole team. I hope to see you soon in person.
Yes. And we invite you for next week for our next meetup, but it's like every week. So thank you once again, and goodbye. Goodbye to everyone. Have a nice evening.